Hello, everyone. I'm Zhihao again. I'm the co-founder and CEO of Genia. So today really marks the beginning of my podcaster's career, and I'm kicking off a new series of podcasts where we invite some of the industry leaders in the construction space. Some of them are our existing customers. Others are industry leaders that have a say in this topic. We invite them on this podcast so that they can share their perspectives. Today, we're really honored to have Dr. Murat Melek joining us from Suffolk Construction. Dr. Melek is a senior director of artificial intelligence at Suffolk Construction. So we're really excited to have you on the show, Murat. Great to have you.
Thank you, Zhihao. Great to be talking with you today.
Nice. So Murat, for those of our audience who don't know you, can you maybe give us a quick walkthrough of your own background? You have a very interesting background combining structural engineering as well as artificial intelligence. So tell us a little bit more about your career choices. How did the two fields come together?
Definitely. I started my career more than 20 years ago at Arup, Los Angeles, about the time when I was finishing my PhD at UCLA. So pretty heavy is structural engineering education, followed by structural engineering work at first Arup, then Walter P. Moore, Los Angeles, Kansas City, and Washington, D.C. And once I started doing design analysis work, I slowly and surely switched more towards technology, starting with visual programming, then Python, then data science, and now full-on artificial intelligence.
Well, nice. That's quite a big of a transition. What was the motivation for you to start exploring automation or Python or Visual Basics, some form of programming while you were doing structural engineering design at the traditional firms, right? So what motivated you to explore the automation solutions?
It's a great question. One main reason was if you look at a typical workflow of a structural engineer while you are designing a gravity system or lateral system or foundation, you repeat the same process over and over and over again. And some of the tasks you are doing, like building models, etc., takes significant amount of time. And after a while, it's not super fun, to be honest. So then the question becomes, hey, how can I reduce the time I'm spending in these somewhat less productive stages of the workflow?
Gotcha. That makes sense. And certainly looking into software programming and artificial intelligence is definitely a value add to that. And as you transitioned your career from a practicing structural engineer and now to some leader leading the artificial intelligence practice in the construction space, can you maybe tell us a little more about what you're currently are working on? What's your vision for building AI in one of the top general contractors in the country?
Thank you. I mean, that's the part, right? I'm working for a contractor, and you might ask, hey, why design is so important for a contractor? The designers, the architects, structural engineers, mechanical engineers, they are designing, they are stamping it, and hey, contractor just go and build it, right? There are several reasons for me being here. And if you were to start, not every design you are getting is high quality. Sometimes there are coordination issues, sometimes because of the tight schedules, deadlines, not all the scope is in there. So there are design scope gaps. You want to make sure that they are there. In addition, sometimes, we have a design arm, Suffolk Design. We design build work. It's not a huge proportion of our portfolio, but there are projects like that too. So how can we basically connect the design side with the construction side in this kind of projects? So in a nutshell, the idea is whether you are starting at 0% or you are starting from 80%, at the end of the day, you are taking data from one end to the other one. How can we fill these gaps, whether it's the 20% or versus the 90% very quickly? It's the task we have at hand.
Yeah, makes sense. You were also working on the automation solutions within the structural design process, and now you are sitting on the other side of the table, consuming some of the structural designs submitted from the subcontractors. Do you see some commonalities in the types of work that need to be automated? And also, do you see some challenges and opportunities from both angles?
I mean, let's be honest, it's impossible to automate 100% of structural engineering work, which shouldn't be. We are doing important work. Mistakes and failures on our designs have catastrophic consequences.
Sure.
But if you were to think about some of the points in that workflow, for example, framing, right? We have been designing buildings across the world with similar outcomes over and over and over again. So the question then becomes, can AI solve that problem for me? I mean, it is not that interesting. You are not solving a super critical problem. And as long as you are checking against benchmark guide rails, you can be sure that, hey, this works, right? So in fact, that's where our collaboration with you, Zhihao, and Genia team, Robin, comes along as well, right? I mean, can AI generate floor frame for you and then use a deterministic simulation engine to check whether that design, that layout is okay? That's where we are at this point. And I think that's super critical thing is you don't want to leave the critical phases to AI. You have to make sure that that beam is sized correctly, has the right depth. You had done the shear check, deflection check, all that things. But at the same time, as Suffolk, we don't want to build a design engine ourselves. And so that's why we are collaborating with you.
Absolutely, absolutely. So let's maybe delve a little bit deeper into our collaboration and what we have built so far. Gosh, it was almost 2 years ago when you reached out to us earlier. You had this amazing idea of connecting the manual piece of the design workflow. And at that time, we were just at the very beginning of our journey of building the technologies. Tell us a little bit more about the vision that you had, and also talk a little bit about what we have built so far. How does it work internally? I know you have also built a very nice chat interface sitting on top of our core capabilities. What was the vision behind that?
I mean, first of all, at the very beginning, we decided that, hey, we are not going to go into the domain-specific engine building business. We are not going to create our own FEM analysis engine or mechanical load calculation engine, etc. So, but then the question becomes, if you are trying to create a pipeline, and that pipeline means that you are trying to reduce the amount of switches from one platform to the other one, then the obvious solution is APIs, right? You want to make an API call to a service and get the data back in a format that you can use. So when we started, of course, there weren't that many solutions 2 years ago that are doing that. So I think it was another LinkedIn post. I saw you and Robin either getting your first one or winning a competition. I said, this is really interesting. These guys are actually utilizing AI in a creative way. And, luckily, we were very open to collaborating. So that was the idea. I'm going to prep the data for you, whatever format, either we are getting from an existing design or we are creating a new one. Can I make sure that it works? And as the service provider, as the domain expert, I'm going to rely on your calculations to make sure that it works.
Yeah, so I guess as a sideline for any construction tech founders, LinkedIn polls are definitely helpful. Social media is definitely a way you should invest in attracting potential customers, just the same way that as we did. I guess just circling back on sort of what we built, which was a structural analysis engine and the layout for floor framing for steel structures. How are those APIs or core capabilities being utilized in the overarching system? What's the impact? Who's currently using it? What's sort of the benefits of using that system?
I mean, we are a contractor. As I mentioned, we have a design arm, mostly architects. We have one structural engineering director. So from the get-go, we said that, hey, the engineering work has to go through APIs. The architect or the pre-con person who was dealing with that doesn't have the necessary domain knowledge or, to be honest, interest to utilize software, structural engineering or mechanical design software, right? So we said, okay, our team is going to do the ETL, right? We are going to get data from the building information model, make sure that it's right, and basically transform it into a schema that is used by Genia, and then get that information back and in the right manner let the user know that, hey, this design solution is okay. So the reason why we started with the non-compact structural steel was one of the projects we were design building included this one-story steel buildings with varying geometries, layouts, and multiple of them in multiple different locations. So the question was, hey, how can I very quickly just change the location, change the layout, send it, and get response back.
If we may call it a sensitivity test in a way, how does that kind of knowledge benefit the team or the overarching design process overall?
As I mentioned, in this case, in the design build process, the architect is trying to come up with a solution, right? Basically, doing their detailing using the 3D documentation software we use. But they need input on whether the solution they are getting to, first of all, not only works, but makes sense in terms of cost, makes sense in terms of coordination, etc. So the ability to very quickly package a solution, send to a design solution, and get the responses back is very valuable for that architect while they are buttoning down on the solution, especially given tight deadlines.
Yeah, absolutely. I want to revisit a previous concept that you mentioned earlier, which is structural engineering decisions, and pretty much any decision in the architectural and engineering practices are so critical. So being able to earn trust and also demonstrating high level of accuracy and reliability is so critical to any software solution in this particular space. Since you have been building AI solutions for people in this field, and you yourself also came from a structural engineering background, are there any best practices or lesson learned in terms of what will be the best way for us to do that? What can you share about what works well, what doesn't work well?
That's a great question. And in fact, it also touches to how we work today, right? I mean, as I mentioned, when I started doing structural engineering in 2004 and progression over the time, what has happened is we started becoming more interested in building 3D models than actually considering options, or at the end of it, like the QA/QC process, benchmarking it against past designs. And that's not the fault of the engineering community. You know, the schedules are tight. You have to run. It takes time to build the 3D models, especially try to figure out what is changing, you know, basically connecting dots, right? Building this 3D. And then you have very little amount of time left to look at the result and try other options. That's not healthy. So the most important part is not necessarily spending time building the model. Yes, model quality is super important. You have to have the benchmarks to check whether the model makes sense. But what is, I think, more important is looking at the results, benchmarking it. Hey, does this make sense? I think especially if you get into this data enriched journey, and this is where AI shines, basically the ability to look at the data and try to make sense out of it, and that transparency that comes with it. So if you are asking me, hey, where should the architects or engineering firms focus on? It is that part. Hey, can I very quickly run solutions, options? Am I able to see what's going out there? If I want to make sure that that beam is okay, yes, maybe it's okay at the 50,000 feet, the benchmarking works, but I want to make sure that the shear on that beam works. Is it available in the report? And that's one of the great things, you know, working with you, Zhihao and Robin, right? Both levels, right? You can be at very high level, you are getting data, but you are also getting element level results at the same time as well.
Yeah, absolutely. I think you touched on quite a few points that we keep hearing from the broader engineering community too, on the job satisfaction, and especially junior engineers often feel like their job is pretty much occupied by manual, repetitive calculations. Robin, who's my co-founder, certainly felt the same way when he was working in the field. Engineers are educated to make critical trade-offs, but then when they enter the workforce, pretty much all they're doing is just doing the manual calculations. That seems to be a little bit demotivating in a way to attract or retain the key talents in the industry. You also mentioned that we need to use AI to the point where we absolutely need it. Can you elaborate a little bit more on that? Where do you think AI is absolutely needed for the parts where we need full observability and full accuracy? Do we need to use AI for that? What's the guardrail around AI usage in this engineering design scenario?
I mean, if you take any building and look at the analysis result, you will notice that it is nearly impossible to go in and check everything. There are certain things you can do, like visualizing, let's say, foundation pressures and try to make sense, say, are these reasonable? Everyone has their rainbow plots, DCR plots, etc.
Right.
But it doesn't go very deep, right? I think the AI enables you to do two things at the same time. One, connect to your old data, make that sense, say, is this okay? But also go in and look into the logs to see whether there are anything fishy going on as well. And even these are happening at the downstream, but at the upstream, I touched to that, right? Connecting the dots, building these skeleton models.
Right.
I think that part, AI is starting to shine. I mean, you have one solution, right? And that's where I think the return of investment is the highest. You can ask AI to create you 3-4 different options very quickly, ready to be run, right? Instead of a graduate engineer spending days just connecting dots while that he or she is not learning much, but just doing busy work. Right. I think that area they shine well. One thing, of course, to discuss is, hey, now you are saying that AI builds the model for me, AI looks at the data for me, AI checks against the guardrails. So how is this young engineer going to become an experienced engineer? I think it's a very valid question. And I think that's more of a user experience question. How do I give that feedback to the user, young engineer, on what is the impact of the design decisions the team has taken and what are the consequences of it? That kind of feedback, which is also missing from the current workflow at this point.
Absolutely. I want to expand on a couple points that you mentioned. We're probably going to leave the labor question a little bit later towards the conversation. On the user experience front, I think LLM itself is not only a technology that's somewhere sitting deep in the tech stack, it's also a very new user interaction methods, right? So if you're a software developer, for example, probably going to be vibe coding a lot of the software engineering or even sometimes training codes if you're developing algorithms through vibe coding. Do you imagine a chat-like interface will prevail in the engineering design, or do you still see precision-based, like a canvas or editor, who will still persist things like AutoCAD or Revit-ish? What's your thoughts on the best way designing the most efficient, also most intelligent way of interacting and collaborating with AI in the engineering design?
It's a great question, and I think it's philosophical debate, right? I mean, when I first started, it wasn't that super important to have a 100% accurate model because all models are wrong, right? You didn't necessarily need to have a 3D model that fits into the architectural 3D model perfectly. Right. So you had certain good practices that also enabled you to avoid structural instabilities in your analysis models, etc. But now we are in a point where accuracy is really important because someone else is using your model to build and coordinate their 3D model. So I think that's where AI comes into place as well. I don't think that a pure chatbot is the way to go, but that kind of back and forth in an interactive manner where you are basically passing on your intent to the software and the software is following on to have the correct analysis model and the correct representation in the architectural model and so forth. Sure. That's super important.
Yeah, absolutely. I think we actually face the same debate every single day, right? So I recall one conversation very vividly in my memory where we were speaking with a structural engineer and then, we generated the ETAPS model programmatically and then she was frightened. So seeing an ETAPS model completely built out of her hands was a very shocking experience for a structural engineer. Not necessarily in this is a very productive way of working, but rather, hey, I'm actually losing control over a lot of the modeling details. So we were always in a constant debate of, hey, do we need to maintain transparency? And hey, are we disclosing too much information so that this becomes a burden for people to validate it? And Matt, I think you brought in a very great point where we should make this a lot more interactive. We should gauge people's intent and then tell them what's going to happen with that intention. So that's actually a great idea that we should incorporate in our user journey as well. And I want to touch a little bit upon accuracy and trust building process, right? So I think you were mentioning that we're seeing a shift where not just in the AC industry, but also in the broader software community, where previously with the SaaS, we're selling the tools and now we're pretty much selling the outcome or results. So how far do you see that we are away from that? And do you think that will be something likely down the road?
I think that shift is going to happen, right? I mean, at the end of the day, if I am the client, do I care how many hours you spent on designing the building, or am I just interested in the outcome, which is high quality design, well coordinated design, and doesn't create RFIs and change orders for me in a compressed schedule? So I think that drive, now the technology is here, inevitably cause change. Of course, some firms are faster to adapt, some firms will be slower, but I believe that that change is going to happen. I don't think that the licensure requirements, the stamping, that's going away. It's a necessary part of the process to add accountability. But at the end of the day, whatever is happening beforehand, as long as the design is correct, as long as the design is cost efficient, hopefully resilient and sustainable, why do I care how many hours you've spent on that designing that building?
Exactly. And I guess as the industry starts exploring with AI, we were talking about the other day where we both agree we should, as an industry, have a set of golden benchmarks because we spoke with a lot of firms. Each firm has to validate the same set of software individually, either through archive projects or through individual testing. It would be great if we, as an industry, have a set of universally recognized ground truth tests, similar to ImageNet, where it kicked off the wave of computer vision, right? So that also ties back to permit review and expediting the permitting processes, right? So from the mechanics or societal standpoint, do you see we are marching towards that direction?
I mean, one thing is interesting is the construction still runs with PDFs. That was some awakening for me when I joined Suffolk, right? In the engineering industry, we built this very nice Revit models. But when you get to the contractor side, they don't want to rely on your model. They build their own. So the PDF is still the king. For the permitting side, it is the same as well, right? The permitting agencies, especially smaller municipalities, etc., they don't have the resources to do a 3D BIM model integration, etc. So I think that the question there is, in the short term, PDFs are not going away. Maybe that becomes the target of that industry-wide standard golden data set, right? In fact, I remember when I was working in Hong Kong, you were able to go to the permitting agency and get PDFs of the building layouts if you wanted to. In the US, it's much more difficult to get that.
Right.
But maybe we just need to start with some kind of PDF golden standard layouts or column schedules. I don't know, something like that. But yeah, definitely industry is in need of such a data set.
Completely agree. As the last part of our conversation, I just want to touch a little bit upon the workforce, right? So you've already touched upon this, the education aspect of this. I don't think structural engineering is the only victim of this. Software engineering, other broader industries where AI is now greatly reshaping the education aspect. And if AI is doing pretty much what junior engineers are doing day to day, then if we're completely replacing the junior engineers out of loop, then after we retire, who's going to become or bridge the experience gap, right? So I guess that's where you were hinting on using AI as a scenario-based education approach as well, which I think is a great idea. So I just want to take from that angle and then ask, what advice would you give to any young engineers, structural engineers entering the field? And how should they think about AI as part of their own workflow? Should they be afraid of AI replacing their job, or should they embrace it? What will be the best practice for you to advise them on usage?
I think domain expertise will be super important. Of course, like you mentioned, companies need to reshape their internal educational programs to make sure that their younger engineers are getting the experience and internal education they need. In fact, you learn more working on the job than you learn during school, let's be honest.
Yep.
And in terms of what kind of skills you need, first of all, I think an open mind, right? I believe the way we do work will change. I mean, in the past, we used to say, you need to, go learn coding. Of course, understanding coding, how the data structures work, how do you deploy, at least, having people around you who knows how to do DevOps is valuable. But more important than that, if our interaction with AI is going to increase. I think the more important thing is the ability to plan and put your thoughts into words in a manner the AI can use, right? I think that ability to communicate, written communication, and putting your thoughts into words and planning will be super important.
That's a great piece of advice. I think at the end of the day, those are also the same thing that keep us human, I would argue. All right, I think we're pretty much hitting on the time. I think thank you so much, Murat. It's a great pleasure having you on this podcast. We had a great discussion. Hopefully this conversation is also helpful to other industry leaders in the construction space and also to young engineers entering in the field. It's a great pleasure talking to you, Murat.
Same here, Zhihao. Pleasant talking with you, and have a good day.